Hey, welcome back. Today let's graph tangent and cotangent. Last time we did secant and cosecant, and prior to that we did sine and cosine. So let's get started. Like usual, give it a shot yourself and then come back and check with me. What I like to do first is rewrite tangent in a more sensible thing for me to work with, right? Tangent is sine over cosine. We're on our unit circle, right? The y value over the x value. So let's start. I'm going to draw a little rough sketch of my unit circle. Okay, let's put in a 0. That's 0. And it's extra useful to write both coordinates out since I'm dealing with both of them for a tangent. So my x value is 1 and my y is 0. So what do I have? Well, if it's y divided by x or sine divided by cosine, I have 0 over 1, right? That's just 0. Okay, so 0, 0. Let's continue along. Let's go to pi over 4. So let's see, what is the sine of pi over 4 divided by the cosine of pi over 4? Well, kind of silly even to write out. We know they're both root 2 over 2, right? That's that 45-degree angle. And if I divide root 2 divided by 2 divided by root 2 over 2, right? Same thing top and bottom, I just get 1. All right, so at pi over 4, I'm at 1. How about pi over 2? Let's write out those coordinates. I have my x value is 0, my y value is 1, and what happens here when I do y divided by x? Bad, right? I have a vertical asymptote at pi over 2. All right, well, I can't cross that. Let's go back this way. Let's go to negative pi over 4. What's going to happen at negative pi over 4? Well, if I go down to negative pi over 4, again, both values are root 2 over 2, except the y, right, in my fourth quadrant is negative. So I'm going to get that same 1 value out, except it's negative 1 this time, right? Negative root 2 over 2 divided by root 2 over 2 gives me a negative 1. All right, let's keep going. What's negative pi over 2? Well, if I go down to negative pi over 2, right, down this way, my coordinates there are 0, comma, negative 1. All right, well, y divided by x, bad again, right? I have another vertical asymptote, so let's put that in. And maybe let's do all our vertical asymptotes. Well, up to pi over 2 was a vertical asymptote. How if I go all the way around to if I go from pi over 2 to 3 pi over 2, right over here, what's happening? I just did that, right? I got a vertical asymptote, but now I'm going in this direction. It's still negative 1 divided by 0, so I have a vertical asymptote. How about if we go from, we went down to negative pi over 2, let's go all the way up to negative 3 pi over 2. Well, this was that first vertical asymptote that we got, right? So again, you'll see any multiple of that pi from pi over 2 is going to be a vertical asymptote. All right, so let's stay away from those. And this doesn't really give me a good picture. Let's get a little more detailed. Let's put in our multiples of 30 here. So let's do pi over 6, and maybe over here is pi over 3. All right, one at a time. So sine of pi over, what do we do first? Pi over 6 divided by the cosine of pi over 6. All right, so at pi over 6, let's draw a new unit circle somewhere. Okay. That last one, kind of ugly, but that's okay. No, it's not okay. Don't settle for anything less than the best. Nice motivational talk there. All right, much better. All right, so pi over 6. If I put my pi over 6 here, I'm going to write out, like I suggested in the beginning, especially for these, your coordinates. Well, my x value is the longer side, right? That's that root 3 over 2. And your y is the shorter side. That's a half. Okay, so y, right, the sine value, y is a half. And I'm going to divide it by the x value of root 3 over 2. This is gobbledygook. Let's take our time and simplify. So I have a half times the reciprocal, right, times 2 over root 3. Those cancel nicely. Looking at 1 over root 3. That also doesn't mean very much to me. Let's rationalize, multiply top and bottom. I get root 3 over 3. Okay, this I could do something with, because like we said when we were doing cosecant and secant last time, really remember two numbers, 1.4 and 1.7, right? And we said square root of 4 is about 2. Square root of 4 is 2, so a little less, with the number 3, we're at 1.7. If you could remember those two, we get all these other combinations out. So if I divide it by 2, I get about 0.8 or 0.9. And if I divide it by 3, well, let's consider this as 1.8, or 18 divided by 3. Well, 18 divided by 3 is about 6, and if we're talking about 1.8, it's about 0.6 here. So root 3 over 3, I'm at 0.6, so let's fill that in. So at pi over 6, I'm at maybe 0.6 is somewhere there. Good enough. Let's put in pi over 3. So sine of pi over 3 divided by cosine of pi over 3. What is this value? Well, now we're up here, right? And these up here, these have just changed, right? Your x value is a half, and your y value is the longer side of root 3 over 2. So let's do this opposite, right? Root 3 over 2 divided by half. This one's a little quicker, right? Flip and multiply. Instead of multiplying by half, let's multiply by 2 over 1. These cancel, and I get root 3, which we already said that was 1.7, approximately, right? All right, so 1.7, maybe I'm up, I don't know, somewhere over here. Good enough. Right, so maybe you can convince yourself that if I went to negative pi over 6 and to negative pi over 3, I'm going to get those same values but negative. And let's look at the picture, right? If we go down to negative pi over 6, the coordinates are still the same, right? This is still root 3 over 2, and this is still, absolute value of a half, but now it's negative, right? I get negative a half. So all this multiplication that we did, division, is still the same, but now I'm going to get a negative root 3 over 2 instead. Root 3 over 3 instead. So I'm going to do negative, and what did we say that was? 0.6. So I got negative 0.6, maybe that's about right here. Right, and I'm going to do the same thing if I came down to negative pi over 3, right? These absolute values are still exactly the same, except the y value is negative. So I get the negative version of this root 3, which we said again, about 1.7. So negative 1.7. And this is what the basic tangent graph looks like. So it follows all the way down that asymptote. It comes up and comes up around like that. It's kind of a little hard to draw, but it looks like this, and it's actually going to repeat. And so I'm not going to do all of them, but let me just convince you with a couple. Let's throw in pi here. What's the tangent of pi? And again, what does that really mean? Well, let's write it out as sine over cosine, right? Y over x. All right, sine of pi, where's pi? Pi's over here. Well, what's the x value? Sorry, slow down. Getting too excited. Graphing. What is the sine value of pi? Well, that's the y value, that's 0. And what is the x value over here at pi? Well, that's 1, negative 1, excuse me. So I get 0. Okay, I get 0, kind of like I did over here, right? If I did negative pi, do I get any different answers? I went pi this way. If I got to pi this way, negative pi, no, I get the same 0, right? So this is going to repeat each time, and I'm going to get that same picture. And again, it's not a lightning bolt. It's this nice curve that kind of comes in. Kind of hard to draw the right little curve that comes in. It kind of like humps a little. But anyhow, let's do one last one. Let's throw in 3 pi over 4 just to super convince you that it looks the same. If I did 3 pi over 4 and I go over here, right? What are my y values and x values at any multiple of pi over 4? It's always that combination of root 2 over 2, right? And another root 2 over 2. Just be careful of the negatives, right? This time the x is the negative. So when I divide these, I get some form of 1, in this case negative, right? And that should be, if I'm telling you that it's a copy, it should be negative, right? And I'm going to end up with positive over here at 5 pi over 4. And so same over here, right? Negative 1, positive 1, negative 1, positive 1. And if you want to fill in and, take your time, practice. Make sure that you're using your unit circle correctly. If you were to put in a multiple of 30 or 60, you should get that same, 0.6 out. And that same, what did we say before, the 1.7 out. So it's going to look like this. Oops, that was an ugly one. Curve. And here is our good friend, tangent. Oh, that was ugly. There's not 2 humps. Me going over this, not helping. Wow, that was the ugliest. But hopefully you get the picture there. Okay. So there's tangent. Let's look at cotangent. And if you remember from last time when we talked about secant versus sine and sine versus cosine, you're going to see a similarity with its reciprocal cotangent. Oh, actually, how about domain and range? Quick. What's my domain here? Anything stopping us from putting in an x value, right? These angles? Yeah. I can't put in pi over 2's again, multiples of pi over 2 going up by pi. So how do I write that? Well, we could talk about it as all reals that aren't equal to, I can't have pi over 2, and I can't go over pi from any of those pi over 2's, right? So I can't have any addition of a multiple of pi, so pi n, right? If I put in a 0, well, I'm at pi over 2. I can't have that. If I put in a 1 for n, I'm at pi over 2 plus pi, which is 3 pi over 2, right? Perfect. How about my range? What could your range be? Well, your range, we usually don't use equal signs. Usually like some colons there, but anywho, what's your range? And again, we always say write this as your teacher wants it, whether it's in like set builder notation or interval notation. We're just talking here together, going for understanding, hopefully. My range, any y value that I can't get out? No, I can hit anything infinitely big or anything infinitely small. So that's all reals. Cool. All right, let's finish up with our good friend cotangent, the last of our 6 trig functions that we're going to graph. And you'll see some similarities again. All right, cotangent, that's the opposite version, right? The reciprocal of tangent, so we're going to have cosine this time over sine. I'll draw a rough little unit circle, hopefully not too rough. All right, let's put in 0. If I put in 0, again, write out your coordinates. My x value is 0. My y value is, sorry, too fast. My x value is 1, and my y value is 0. And so cosine is in the numerator this time, right? Your x, so I have 1 in my numerator. That's the cosine value. I have 0 in my denominator. That's the sine value. Bad. Oh, interesting. Okay. This time, my asymptote is on 0. All right, keep going. How about pi over 4? Well, if I put in the cosine of pi over 4 over the sine of pi over 4, you probably already know the answer, perhaps, right? I'm over here at this 45-degree angle. Both cosine and sine are the root 2 over 2's, right? So root 2 over 2 divided by root 2 over 2, 1. Okay, so now I'm at 1. How about pi over 2? Well, let's put in pi over 2 up here, right? What are x and y? My x is 0, my y is 1. Okay, so x is 0, so I have 0 over 1, which is 0. All right, so at pi over 2, I'm at 0. Maybe it goes like this. Let's see. Let's put in 3 pi over 4. 3 pi over 4. All right, if I'm at 3 pi over 4, sorry to kind of write over stuff, same values as before, right? Except 1, because it's, again, a 45, 45, 90 triangle, except 1's negative. So I'm going to get out a negative 1, right? So now at 3 pi over 4, I have negative 1, and maybe you can kind of, after doing tangent, you can think, this is probably going to look similar. How about pi? If we go over to pi, well, let's write out carefully our coordinates. The x value is negative 1 and the y value is 0. I have x, right? Cosine is x. X over y, so that y is 0. Bad, right? And you probably guessed that was going to happen just by knowing the picture of tangent, right? So this time, now my asymptotes are every multiple of pi, right? So I have 0 asymptote, pi asymptote. Right? So if I go back to 2 pi, again, divide by 0, right? Asymptote. If I go the opposite direction to negative pi and to negative pi over 2, right? Divide by zeros again. So those are your asymptotes. And if you want, I'll leave it as an exercise for you. You're going to get those same values of 0.6 and what else to get? 1.7. If you put in those multiples, right? If you put in pi over 6 and pi over 3, right? You will get out 0.6 and you will get out 1.7. And so you're going to get that same picture as before, well, similar picture as before that we got with tangent, right? So the asymptotes have shifted over by pi over 2, and we'll talk about shifts eventually. And now it's facing the other direction, right? We have this nice smooth curve this way, but now it's going this way. And again, if you want to convince yourself that I'm also at 0 here, well, let's check. At 3 pi over 2, well, I'm at pi over 2. How about 3 pi over 2? Well, my coordinates are the x value is 0, the y value is negative 1. Cotangent is the x, right? Cosine over the y. It's the sine. So I'm at 0. Yep, I am at 0. Right? Put in the multiples of pi over 4. You're going to get that 1 and negative 1, right? And you can continue these, and you will get these. And again, it's good unit circle practice to get faster and more familiar. But to save time, I'm going to fill those in, and you will get that smooth curve just like before that we got. And it looks something like this, right? And it repeats. And there, my friends, is, that one was ugly, is, well, this last one is cotangent, right? And very similar, again, to finish it up with domain and range. What can you put in for a domain? Well, I could put in any angle I want except those bad values, right? Except I can't put in 0, I can't put in pi or 2 pi, right? So any multiple of pi. So I can call that pi times a number, right? Pi n. And for your range, that one's the easier part, right? I can get any number out for my output, right? I can get any y value I want. Super big ones all the way up there if I follow that asymptote up, or super small ones, or super big negatives, however you want to think about it. Right, so there's tangent and cotangent. Make sure you can do them without watching me, and we'll see you next time. Thanks for watching, and please subscribe to After School Extra Help. Also, leave a comment if you'd like more examples, or if you want another topic to be covered.